different pathways that can be taken to synthesize sulphanilamide. So, but one of Alright, so we're looking at the synthesis of sulphanilamide. We have six steps that have to be followed. Now, I need to let you know that in the synthesis of sulphanilamide, there are different pathways that can be taken to synthesize sulphanilamide. So, but one of the most probable pathway that you most likely find in the synthesis of sulphanilamide is this pathway that I have been choosing. So, depending on what your lecturer teaches you, if he teaches these exact steps, then you are good to go. But the principle around them is still similar, because at the end of the day, there are some steps here you can skip. I don't know if that makes sense to you. So compare this what you have in your lecture notes, and then it should be able to inform and guide you on the specific areas that are not negotiable with regards to the synthesis of sulphanilamide. All right, so the first step we have in the synthesis of sulphanilamide is the nitration of benzene. Second step is reduction of nitrobenzene, acetylation of aniline, chlorosulfonation of acetanilide, and then amination, and then hydrolysis of acetamide group. So the first step I said is nitration of benzene. So we call this step number 1. Then this is going to be step number 2. Then this is going to be step number 3. This is going to be step number 4. And this is going to be step number 5. And finally, this is going to be step number 6. So we're going to be talking about these steps one after the other, so that you can have appropriate understanding that will aid your comprehension of the synthesis of sulphanilamide, which is a breakdown from azo diprotosyl. All right, so the first one is nitration of benzene. So this is a benzene ring. This is a benzene ring. And then for us to get benzyl nitrated, we still use similar formulation we used in the synthesis of the benzocaine, which is nitric acid and H2SO4. I remember that while we were talking about the synthesis of benzocaine, I did remember mentioning that what happens here is that the nitric acid is protonated to form nitronium ion. Which is NO2 plus to form nitronium ion. So that nitronium ion is the electrophile. You know, I told you that electrophiles are electron deficient, so they accept electrons. So, and to show that they are electron deficient, you find out that the charge is positive. You must have watched the video, or should have watched the video where this has been taught, or probably in your class, about what electrophiles are, nucleophiles are, electrophilic substitution, nucleophilic reactions, and the like. So this is an electrophile that's electron deficient, and by implication, it can now attack the benzene ring and replace one of the hydrogen on the benzene ring. So this first reaction is an electrophilic substitution, because it involves an electrophile that was generated from the protonation of nitric acid, forming nitronium ion electrophile, which substitutes hydrogen on the benzene. So it's an electrophilic substitution process, and then you now have what is called nitrobenzene. So what we now have now is nitrobenzene. All right, so nitrobenzene has to now go through the next step, which is the reduction of nitrobenzene. What are we reducing on the nitrobenzene? What we are reducing on the nitrobenzene is that we want to reduce the nitro group. We want to reduce the nitro group into amine group. We want to reduce the nitro group into amine group. So that's basically the reduction process. So there are different reagents that can be used for reduction. You can use iron and hydrochloric acid. You can use tin and hydrochloric acid. That is if you are working with the chemical process for reduction. You can also choose to use catalytic reduction, where you can use things like nickel and hydrogen gas and the like. So there are different reagents that can be used for the reduction, but the basic thing is that what we need to do is a reduction of nitrobenzene. So, but for this particular equation of reaction, we're going to be using tin and HCl for our reduction process. We are going to use tin and HCl. So your lecturer can choose to use iron and HCl, Your lecturer can also choose to do a catalytic reduction. Catalytic reduction will involve the use of hydrogen gas and nickel catalyst, and there are other things that can be used. So it depends on what you're taught. I hope that makes